Hello, serhii. I got your email and I apologize for it taking so long for me to answer you today. I was in meetings all day and just have now had a chance to get back to the computer and answer your questions. I've decided to make you a video to talk about the 3 questions that you asked me. Starting with the first one, this is part 1 of the 5th question. And so what you need to do here is find a function. You have to find the equation of the function, and it's going to give you some information that will help you to do that. For instance, if it says that we have a vertical asymptote at x equals minus 3 and x equals 4, then we know that those are values that will make the denominator of our function equal to 0. And so we know that our function must have factors of x plus 3 and x minus 4 in order for that to be true, because if we substitute in x equals minus 3, for instance, we'll get 0 in the first bracket, and that will give us an undefined value for this function. So the graph is undefined when x equals minus 3 and when x equals 4. Now, a hole is a little bit different. With a hole, it looks like an asymptote. So we would start with that in the bottom. But with a hole, we may be able to remove that discontinuity in the graph with a factor in the top that has that same factor. And so in that case, we would want to build in a factor like x plus 4 in the top. So initially it looks like we would have an asymptote at x equals minus 4, but that's going to cancel out with that later on, and so that's how we deal with that. Now, with a horizontal asymptote at y equals 0, your horizontal asymptote comes from having a constant on the top and a variable in the denominator. Something like, for instance, something like 1 over x would have a horizontal asymptote at y equals 0. And that's because if I let x get very, very large, in other words, it's going to approach a value of infinity, then 1 over x becomes very, very small and approaches a value of 0. And so whenever we have a situation like this, we have a horizontal asymptote of 0. So I'm going to leave it to you to work out how you would put that into the equation, how you would build that into this particular equation. And the other part of this is a y-intercept of 0.5. Now we get a y-intercept whenever x equals 0. So once you've got everything else in your equation figured out, you want to go in and make all of these x values equal to 0 and adjust your function by multiplying by a number so that you would get an answer of 1 over 2 for y if all the x values were equal to 0. So I think that's all I'll fill in for this one for you, because on the real exam there's a question that's very, very similar to this one. Let's go to the next question. And again, I had a little bit of difficulty determining which question you were referring to here, because it's a choice. And on the exam it will be the same idea. There'll be 2 questions to choose from. And so both questions are different, and I'm not sure which question you're asking about, which one you were attempting. And so, excuse me, if you are attempting the first one, then in the first one they're giving you this equation, and they're asking you to be able to read certain information from the equation or to be able to work it out. For instance, part A asks you for the diameter of the Ferris wheel. And so the diameter of the Ferris wheel will be if this is a sinusoidal function, it'll look like this when you graph it. And so the diameter will be the amplitude between the highest and the lowest point on this function. At what height is the rider off the ground at x equals 0? That's simply a matter of substituting 0 in for x in the equation and calculating the y value. And how long does it take for the Ferris wheel to go through one complete rotation? So for that, you need to determine what is the period of the function. And once you've figured that out, and you know your period is 2 pi over k, then you can solve for x for one period of the function. And so you could make y into, once you know your period, you can substitute that in for y and solve the equation for x to find the number of seconds that it takes to complete one period of the sine function. Now at the bottom question here down here, this one's a little bit different because this one is asking you to create two equations. This one is asking you to create a cosine function, and this one is asking you to create a sine function. You should be able to do either with the information that you're given, because remember the sine function is just 90 degrees different from the cosine function. The sine function looks like this. It starts at 0 and ends at 0. And the cosine function is 90 degrees behind it. It starts at 1 and ends at 1, like that. So in this case, they're giving you some information. We have a maximum population of 15,000, a minimum population of 500, and at the beginning of the year, the population is at its greatest. And so the easiest way to start a problem like this would be with the cosine function, because if the population is at its greatest, then it tells us that we're starting at 15,000. If the lowest population is 500, then my graph here would not be correct. It would be a graph that would look like this, because 500 is the lowest value, or the minimum value for this function. And so you will take the information and determine from the graph the amplitude, the period, and the vertical and horizontal shift, so that you can create a sine function or a cosine function for that information, okay? So again, in part 3, question 3, there's 2 sections to that question, and it is a choice. You only have to do one, so pay attention to that on the exam also. And these are both logarithmic applications, where you're given a decay or growth example, and you have to solve for some unknown using your formula. So if you were to choose to do A, and again you didn't indicate, I don't believe, which one you were choosing, let me just check and see. I just checked your email again and had a quick look, and there's no indication which problem you were working on in each question. So if you were doing A, they're giving you information so that the first thing you can do there is find the rate of decay, or the decay factor. If you're starting with 25 and you end up with 20, e to the kt, and in this case, because it's decaying, it's e to the minus kt, then we know that t is 42 hours, and we can solve for k using logarithms. So we have 25 over 20 equals e to the 42k. And so if we take logs of both sides, we would have log of 1.25 or ln, equals 42 k ln e. Let's change, sorry, ln e. Let's change this to ln rather than logs of both sides, and it won't let me erase for some reason. Okay, so we'll just cross that out, I guess. Sorry that's so messy. So we've got ln, I'll just rewrite it, ln of 1.25 equals 42k ln e. Now ln e is equal to 1, and so k is going to be ln of 1.25 over 42. That's going to give you your growth factor, or in this case your decay factor, and then you can use that in your original formula to set up, if you want the half-life, you could start with 2 and end up with 1 e to the kt, so that you started with twice as much material and now you have half that amount. You'll know k from what we've just worked out, and you'll be able to solve for t the same way that I showed you, okay? So for question B, this is a growth question because you're making interest on your money. And so if we triple $5,000, what we want to accomplish in part B is we want to have $15,000 at the end. We're starting with $5,000. And we are making 12.5% interest. We just don't know. Oh, sorry, it's not 12.5, and it's that's a quarterly amount. So we would divide that by 4. So that would be 1.03 125, I believe. And then we're going to put n up here, and that's going to be the number of quarters that you would have your money invested for. And so 15,000 divided by 5,000 is 3, and we have 1.03125 to the n. And so again, taking lns of both sides, ln of 3 equals n ln 1.03125. And you can solve for n by bringing this ln over here and dividing it into that ln. So I hope that helps. Again, it was a little confusing for me because I didn't know which questions you were referring to in the last two. But the real exam is very, very similar to this exam. So if you can do the questions here, then you should have no problem on the final exam.